Hi everyone, I'm Filippo Pini, young researcher from the University of Bologna, and today I will present you the Model 4, Unit 3, Integrating Behavioral Evidence and Exploring Policy Pathways. In this unit, we will answer these three guiding questions. So, how can behavioral evidence be integrated into system dynamic models? Then, how does behavior shape system responses and trajectory over time? And to end with, how can behavioral system dynamic models support policy design and evaluation? To do that, we know that from the previous unit that we have a system dynamic model, so a behavioral system dynamic model, how to shape that. We run the simulation, as we saw in the previous unit of this module, and then we have the behavioral insights, how we saw in the module 3. Having all these three characteristics, we create an information loop between system dynamic and behaviors to understand how to create effective policy mixes and to take decisions. But the simulation depend on what? Depend on the kind of behavioral responses that the farmers and the agents in general have on some different policies. What does it mean? That the same system can lead to different outcomes. And how? Because in one case we have positive behavioral responses and then create a positive outcome. On the other side, we have negative behavioral responses that lead to negative outcomes. But why the behavior matters for decision? Because the same policy design, the same policy mixes can have a low behavioral support that lead to a weak effect, and on the other side, an high behavioral support and can lead to a strong effect. The difference is in here is the responses from the individuals that can support or not the policy mixes integrated in the system. In that sense, behavior shapes the policy impact. How we want to do this information loop and the integration of behavioral insights into the model, creating an informative feedback loop between system dynamic and behavioral insights. How we do that? We run some baseline simulation on the system dynamics developed in the unit 2 of this module. From the simulation, we add some systemic leverage points that come out from the simulation. On that, we do some stakeholder consultation with the case studies, with the relevant stakeholders of the system that we are analyzing to understand which of these systemic leverage points are the most relevant. After that, from the systemic leverage point, we can create some system-informed attributes. The system-informed attributes help us and drive us to create discrete choice experiment that are characterized by attributes and levels. Running the discrete choice experiment as explained in module 3, we have as result relative importance and relative utilities from the discrete choice experiment. Then we can run some normalization and aggregation from this output of the discrete choice experiment to create the behavioral multipliers. There will be, and here is the novelty, will be embedded directly in the system dynamic models. But from the behavior to the model responses, what we should do and what we are going to do. The behavioral evidences that come from the discrete choice experiment can lead to the behavioral multipliers that we saw in the previous slide, and these multipliers will be embedded in the model simulation. What are these multipliers? Let's say that this multiplier are some a sort of calibration, a behavioral calibration of the model, in which the multiplier can be between 0 and 2, and 1 create no change on the system, is a neutral, have a neutral effect. If is above 1, we have an amplification of the dynamics of the simulation, and if it's below 1, a dampen of the dynamic of the system dynamic. In that sense, we are directly embedding the behavior in shaping the system dynamics. But how we are creating these behavioral multipliers, and where are these behavioral multipliers derived from? As I said, the behavioral evidences that come from the discrete choice experiment, so all the set of results are characterized by the importance that reveal us how relevant a factor is, and the direction of the behavioral insights, so that can encourage or discourages the behavior. Through a normalization and aggregation process that create a single behavioral multiplier, so a single number that is indeed a multiplier of the system dynamic, we are creating the system dynamic that are normalized and bounded between 0 and 2. Then we can have some policy mixes, some policy scenarios. Because from the discrete choice experiment, we have a set of multipliers that are multiple and represent a different kind of attribute. There can be the subsidies, the amount of subsidies, the length of commitment of some contracts, the amount of training hours, and many different kind of policies or actions that can be embedded and integrated in the system. If we select a set of multiplier, so different kind of behavioral responses from training, amount of subsidies, length of commitment, we create a policy mixes. And then we can run simulations in the model, and different kind of policy mixes lead to different scenarios. So we can then analyze directly how the behavior of farmers, of individuals in general, really can shape and differentiate the system through years. This behavior should be considered as a modulatory component of the system. As you see here in this figure, the behavioral multiplier is not an exogenous event or an exogenous variable of the system, but is embedded into the system and is connected to the variables from which we derive the first systemic leverage point. This means that the behavioral multiplier does not act externally, but only internally in the system dynamic model. And this behavioral multiplier modulate existing system variables and systemic relations. After that, we can arrive from the leverage point to the behavioral mechanism, having a feedback loop, an information feedback loop between leverage point, discrete choice experiment attributes, and behavioral multipliers. In that sense, we are embedding all the behavioral insights that we analyzed in the module 3 in the system dynamic models developed in the unit 2 of this module. This lead to the fact that leverage points highlighted in the system simulation are totally behavioral grounded by now because we created this information feedback loop between system dynamics and behavioral calibrated multipliers. So all the system variables are now grounded on the behavioral insights and calibrated from the behavioral insights. In the end, the behavior activate or dampen the system change, as in the reality where the individuals and the individual behavior can influence the system and is influenced by the system. To end this unit and this module, we can say that from a single intervention, we can create policy mixes that represent the reality or some future scenarios. In that sense, we have, just for an example, multiplier A that is a higher level of subsidies that has a high and positive behavioral responses, multiplier B that is related to training, and multiplier C that is related to regulation or commitment length. If we combine these three multiplier, creating a sort of policy mixes or interventions, we create different policy scenarios. In that sense, what we are doing is creating policy scenarios that are grounded on behavioral insights and in system dynamic models. So we can analyze also how the behavioral of farmers can be differentiated through the years and how these behavioral insights can really shape the system.